Our last transformation, the c transformation, is a constant added to the variable but still inside the function. This is going to be some sort of horizontal change, and since it's addition, it's going to be a horizontal shift to the left or to the right. And if you remember from function transformations earlier, adding a constant actually moves our graph, shifts it to the left, and subtracting a constant shifts our graph to the right. Those transformations working on the variable work opposite of what we would expect. Like our d transformation, when it was positive we shift up, when it's negative we shift down. That makes sense to me. But when we're addressing the variable inside the function, it works opposite. Add c, shift c units to the left. Subtract c, shift c units to the right. We're looking at our base function sine x in maroon, and in green we have a c transformation. We have added pi over 2. It's added, so we're looking for a shift to the left, and we do see that the graph in green is shifted left of the maroon graph, and by how many units? Pi over 2, that's 90 degrees. So I could see a shift of 30, 60, 90 degrees. Every point that I see on the maroon graph, if I shift it left by 90 degrees, I will land on the green graph. 30, 60, 90 degrees to the left. Something that's a little ambiguous here would be, well, could you say that I've shifted my graph to the right by 3 pi over 2, by 270 degrees? And I would say we can, with the algebra of these trig functions, show that it is true, that shifting to the left by pi over 2 is exactly the same as shifting to the right by 3 pi over 2. We'll get to that later, but now let's look at this shift in smaller increments to really see what sort of shift is happening. Here's pi over 10, adding in pi over 10, so we're just moving to the left a little bit. Pi over 9, so as we're increasing our value of c, we can see that we're moving this graph further and further to the left. So absolutely, when we see a constant added to the variable, we know that it is producing a shift. And a constant added will shift to the left, a constant subtracted will shift to the right. But as always with these trig functions, there are going to be a few possible transformations that lead to the graph, the transformed graph that we see. Here I'm attempting to illustrate shifting it by 2 pi. Now we know that 2 pi is our period, so if I shift it an entire period, I'm going to land on the exact same graph. Here is the result that we've seen a couple times now. We saw it from a reflection on the x-axis, we saw it from a reflection on the y-axis, and now we're showing it as a result of a shift, a horizontal shift. Plus pi, so you could say we've shifted it to the left by pi units 180 degrees, but it looks identical to a shift to the right of pi radians, or 180 degrees. Again, knowing the properties of these trig functions will show us that different transformations can lead to the same result. But we need to cover a very important detail about the horizontal shift. We're back to sine x and sine of x plus pi over 3, so we're shifted to the left by pi over 3 radians, or 60 degrees. If I focus on this point right here, this peak, and I go backward by 15, 30, 45, 60, okay, I land on the peak of the green. Or if I look at these intercepts back to 15, 30, 45, 60, so definitely seeing this shift to the left of 60 degrees. But what if I decrease the period of these functions by going with sine of 2x and sine of 2x plus pi over 3? I'm still seeing that same value of c pi over 3, but what is the shift that we see here now? From the maroon graph, shift to the left only 15, 30 degrees this time. I can really see it with the intercepts. Shift to the left 15, 30 degrees. So something about changing this factor b is having an effect on our horizontal shift. Let's look at this a little bit further. Sine of 4x and sine of 4x plus pi over 3, now our shift is only 1 unit by 15 degrees. Before, when we were first talking about the b transformation, we said it would shorten your period. Take your original period for sine, it was 2 pi, and divide by this factor, and it gives you your new period. Well, when it comes to our horizontal shift, this also must be divided by that factor, the b transformation, the b factor. In this example, pi over 3 divided by 4 would be pi over 12. That's 15 degrees, the exact 15-degree shift that we see in this example. Back to this one, pi over 3 divided by 2 would be pi over 6. That's 30 degrees, the shift we're seeing here. When it comes to describing what the effect of c is on a trigonometric function, we really have to be careful and work in that b is also going to have an effect on this horizontal shift. We could say that negative c over b is the phase shift. We saw that from the graphs that we would want to take this constant c and divide it by b to get the actual amount of the shift, and we also said that adding c would be a shift to the left. So if I want to talk about a shift to the right, this should be a negative c. The specific terminology we see with trig functions is the term phase shift. That's our horizontal shift. If the phase shift is positive, we say that's shifting to the right in the positive horizontal direction. And if the phase shift is negative, we're talking about shifting our graph to the left in the negative horizontal direction. So we account for this difference in signs by saying make it opposite of c over b. So if I see a plus, which I know is a shift to the left, this expression will give me a negative result. And when it comes to phase shift, negative means shifting to the left. If this was minus c, then this expression opposite of negative c over b would become positive. And minus c we know is shifting to the right, so this expression will give us a positive number for phase shift. So we know when we see a positive phase shift, that's shift to the right.